Okay, welcome to LangChain4j with Quarkus. I'm Max Andersen, the D at Red Hat, Quarkus co-lead, and from the country.
Konstantin, Konstantin Pavlov from Twilio.
And yeah, we are here to talk about Quarkus. So, but first off, who in here actually know or use Quarkus? Good ones. Okay, cool. So first of all, just why Quarkus? Well, Quarkus has been a thing we created to make Java fun again and better, just like Kotlin is trying to do, but without changing the language. But we work with Kotlin. So the best way of showing what Quarkus is about is to actually show it. Let me go back here. So Quarkus has a command line where you can create an app. So if you create an app, it comes in Java. If you want to make it to Kotlin, then you can do it here. So you can add different extensions and stuff to it, but we just do a very hello world demo here. It'll create an app, and now you're a happy owner of an app. And I'll go and open this up. Google Quarkus. And in here is a very super advanced example of a hello world REST endpoint. And if I go and run this, so I can do like, what was it called? SDK&V, I need to set this up. There. Sorry. Go back. Here we go. So Quarkus dev, I can also run, we can use Maven or Gradle. I'm just using Maven here for the easy default. And it builds a project, and it starts up. And the thing, Quarkus has a thing called dev mode, which we'll get into, but in here I can press W and it shows my super awesome app. It has a hello endpoint that says hello from Quarkus REST. And I can go back and then say, from somewhere, from plus where, and the function is where, and can I spell? There we go, equals Kotlin conf in Copenhagen, and I can't spell my little language here. There we go. I go back and I reload, and it should there. Right. So what I did here was I reloaded an application from scratch. We call it lively load. And the nice thing, it works even if there's 1,000 entities in here, like a Hibernate stack or something like that. Same thing. It gets this developer experience running. Other thing is I can press D and I get into what we call dev UI. And in the nice thing, Quarkus has this understanding of development. Everything comes out of the box. I don't even have to use an IDE if I wanted to. There's actually an editor in here that lets me see the source code and go like, hey, I spent this was Kotlin conf 2025, and save it and go back, and you're there, right? See the build log down there. So everything comes built in. You don't have to do anything to get a developer experience. Of course, it works with IntelliJ or VS Code or that kind of thing, but we have a high focus on development experience here. Where must I go? Whoops. Go back. There. So super easy to get started. The stuff we do around Kotlin is done in a way, we'll see more about in a way that is quite transparent. But the fundamental of Quarkus is built to write Java applications on the VM and for native image. We focus very much on cloud native and microservices and serverless, and recently now all the AI, because who isn't? But we actually feel like it's really well suited for it. You'll see Konstantin will actually be showing how to do prompt engineering and editing in this whole dev reload cycle, which is nice. But the whole point is that this is kind of what we mainly focus on, but there's nothing in Quarkus that prevents it from being used for everything else, right? Yes, we don't run on Android, but you can be a CLI, you can be a microservice, be a monolith, you can be a batch job, you could be an admin tool somewhere. Different architectures. Quarkus is a generic framework, just like other frameworks like Spring or Micronaut, that kind of thing. Quarkus is in the same class of things. And what makes Quarkus different is we have these 4 principles that we follow quite strict. That we want to have developer joy or frictionless development experience. So I showed a lot of that here right now. We'll see more. get anything built in. And for me personally, I've done a lot of tooling in the past where I did Eclipse plugins and IntelliJ plugins. And I was like, hey, I think this is great. People are using it. But I learned very quickly that even though there was like millions of users of JBoss, people were maybe only 5% was using my tool. And I was like, why is that? Well, because they have to install a plugin into their IDE. They just don't get to it. So Quarkus just flips that around, and you don't need to, but it gets better with IDE. But all the hot reload and that stuff is just there. Then there is the build time principle. So we talked about dev mode. There's also a build time part, and this is the key part of Quarkus. It is moving everything we do at runtime, everything we can do at build time, we move away from runtime. And why do we do that? Because we are now in the old young days of Java, 20, 30 years ago, we all run on big, massive machines, and we start up once a week or maybe once a year, and it didn't matter that it took a few seconds or minutes to start up. Now it's really important because we only have these small containers and they only have limited resources, and we want to do continuous rollout and continuous updates. So the startup time becomes important. And when you look at what Java does normally, at standard Java application, they spend a lot of time at runtime in the beginning, to boot up to the state they've started up in the first 1,000 times in the last week or two, right? So why not just do that at build time? We do that inherently, and that is one of the main things, like why Quarkus is so fast. We can do the development mode very fast, and we can start up, but also we save memory, because we no longer need XML parsers or JSON parsers and that kind of thing to read configuration at runtime. We just kind of build it in and boot it up, and all is gone. All is done. So those focus on development time and build time makes it that the runtime is smaller, leaner, and can handle way more than a traditional framework. And the way more comes from Reactive Core, is that all Quarkus built on is Vertex, if people know that. It's a reactive thing that we can handle all I/O and utilize with way fewer threads than normal. But the very cool thing is you do not have to care. Quarkus does not require you to use reactive. There's a lot of people who think that's true, that's the case, but it's not true. Like the default we recommend and push on people is, please use blocking just as you used to. You don't have to use reactive. We take care of that for 90% of the cases. So that means if you're taking a normal Spring app or Jakarta E app that you're used to and port it over to Quarkus, in many cases that alone will get your, like, shave off 50% of your startup, 80% of your memory, and when you do native image compilation, like it goes down to almost nothing. But that's the thing we've been doing for 8 years now. But the thing that people don't tend to remember is, well, once everyone does native image, the benefit doesn't go away. Well, you don't even have to use native image to get all the throughput benefits we have. And that's what comes from the Reactive Core. And again, your user code doesn't need to care. We have the Reactive Core, so we deal with that stuff. And it's also all these 4 parts, frictionless development, the build time, and the Reactive Core is why we can fit so well in with Kotlin, right? We handle coroutines, we handle serialization, the data class, that kind of thing works. So it works, all pretty nice. Sorry. But we're here to talk about AI. And I just talked about all the complex stuff you can do. Let's go back to basics. This is, oh, sorry, I want to do the slide first. Yeah, the word is similar to AI. This is one file JBang script. Anyone here knows JBang? Oh, you should, yeah, you know, I know. Anyway, JBang is a little utility that can run scripts or multi-file scripts, and from dependencies. So you can do this in Maven, but then I have to have like 6 pages to show it. Or Gradle, 4 pages. Anyway, this on top, I just say go get Quarkus, Pico CLI, and the LangChain4j OpenAI API. And now I have Quarkus will dependency inject the chat model into my my class here, and then just access the AI. Right? That's all you need, and it looks like this. Just to prove I'm not making this up. This is the code. I just go JBang. That was a very loud JBang. JBang. Jokes, right? So it will build it. Oh, it didn't build because I didn't change anything. So Why do Kotlin developers in Denmark always bring a ladder to work? The best way to reach the higher order functions. Okay, no, that's actually almost funny. And I don't know, and Quarkus. So just to show that it actually works. I can't spell it. There you go again. So you see here, then now you know to take the chains, we build it, and we run it, and off you go. And it will be even worse, little hygge and a lot of coroutine. Okay, yeah. It's not a best comedian. So anyway, the point is, with Quarkus and JBang, but Quarkus itself, the declarative model is quite compact. Nothing else needed. You can get started on this stuff. But again, there's more highlight. So what happens here? Well, there was my application that used Quarkus LangChain to get dependency injection, and then use LangChain4j, the library, right? And the separation up here is very explicit. LangChain4j has 0 dependency on Quarkus, and will never have a dependency on Quarkus. Is a library that's intended to be used everywhere, including Spring and Micronaut. That's there. I say that LangChain4j is the Hibernate of AI. It can be used anywhere. Can use all the models you have there. And we are very keen on making sure this is not tied to any specific framework. Like Spring AI is tied to Spring, Quarkus is not. Right? The LangChain here is independent. But Quarkus brings all the enterprise features, all the boring stuff, like observability, auto-sync, resilience, some higher level agent stuff that we will show a little bit of here, but it'll come more. But they're very important that these layers are there. LangChain4j is an independent project. Quarkus LangChain just kind of makes it enterprisey. And so you can shorten stuff. So for those who don't know, like LangChain is, let's say, the lower layer of, well, not lower layer, but the middle layer to AI, so we can access all these different models out there, like model providers like OpenAI, Watson, Anthropic, Vertex, OpenShift AI, Olama, and there's probably more on this list that I haven't added. Different embedding stores, again, remote ones that run somewhere, and even local ones that runs in memory or in process of Java. So you can actually do small models, locally. LangChain4j itself can do agents and tools. You've probably seen like a ton of these different versions, but just to explain, when you talk to an LLM, you'd say, hey, solve this problem, and you can give, there's some tools you can call. Those tools can be CDI bean, like, so it can be code you have that's in your Quarkus app, and they be added with this annotation. They can also be MCP tools we'll get to. And so again, in Quarkus, we get this declarative model where I have a service that can make a poem. You can see there. Write a single topic about the topic that comes from this parameter, and the lines is here. And the cool thing is that this is all compile time safety. So Quarkus has this build time phase where it actually gets the annotations and extract it and compile check that these things work. So if you change any of these, you'll actually get a compile error. And then we say here that you have access to this email service. That email service is just any other bean that here it says send an email with a string and send it with the mailer. And the mailer comes, of course, from the Quarkus extension. But that mailer could be anything else, like anything from the Quarkus ecosystem that's there. Okay, in the dev UI, you have ability for seeing a different extension. Every extension can contribute like developer tooling. The LangChain4j adds like this whole, you can chat to the model and check if your prompts are correct and your tools are correct. You can debug what they're doing. And again, this comes with batteries included. You can run this on your laptop without having any ID installed. This will be there. Just to highlight the server, so these tools I showed was embedded in the process. But if you want to use an MCP server, you can do that. Konstantin will show like using non-Java ones. This is just showing that the Quarkus MCP server SDK works with Kotlin. This is a different SDK than the MCP because the MCP at Anthropic depends on stuff from Spring, so it can't be used everywhere. So here we again have a class demo with a tool, hello with a text, and that's enough to have a start of an MCP server in Kotlin. There's some links here if you see more details. And actually today we supported a version for the new streamable SP, for those who know in MCP. That came out today. And it should work. I haven't time to try it with Kotlin, but it's all just the same thing, so it should work. Good, but now.
Thank you, Max.
Yeah.
So today we want to show a demo of AI assistant, a virtual agent, which is communicating with the customer through WebSockets. It can maintain conversation. It can answer questions based on the documents uploaded to the system, and it can communicate with external tools, do content moderation, and of course, communicate with language models. So this is a QR code, and let me start. Here it is. Okay. Oh, can't see. And this is different project. Oh no, stop. It's this one. So we have our server running. I press W. It's web UI. Loading. Oh, takes time. Yeah, here it is. And we have sample questions here. And let's ask our assistant about financial advice. For example, I have 10,000 euro. I want to spend it. And assistant answers with some financial products pre-uploaded to the system. And this is RAG, Retrieval Augmented Generation pattern. So how we have it implemented, we have a folder with some documents. And this is information which is used by AI assistant. So how we can enable it? Very easy. We have this EasyRAG component from LangChain4j, and it's extended in Quarkus, and we should provide a catalog folder. We should provide a path, and then we should provide how we want to split documents into chunks, how chunks should overlap, and how many documents we want to retrieve from vector database and send it to a large language model. Let's take another example. For example, about time. Language model is trained on some static data, and it doesn't have access to real-time information. And here we can use some Java, Kotlin or Java method, or we can use MCP. For example, I'll ask a question, how many hours do I have today to visit your office? Yeah, so it knows current time, and it gets this current time from calling MCP server. And we can configure it also almost declaratively. Here, yeah, we call podman, and we call MCP time Docker image. We communicate with the Docker through standard I/O, but it's possible to use HTTP server-side events protocol as well. So we defined this MCP server, and then Quarkus has created a bean and injected it into context. So in our business class, we can get this MCP client, and then we should provide MCP to supplier, and we should provide it to assistant. And the assistant is our main class, which is containing. Here we describe how we want to build our assistant. And we not write a Kotlin class, we write only interface. And we have this register AI service annotation, which instructs Quarkus LangChain4j extension to generate code, bytecode actually. And then we can provide different tools here. For example, tools, we can provide language models, parameters, we can provide chat memory, moderation, etc. And also we have this method, it's called chat, and we annotate this method with a system prompt, and we can take prompt from templates, we can hard code it here. Also we provide user message, which becomes a user prompt, and we have this parameter interpolation, so we just give a name, and if we compile with parameters enabled, then value is injected by name. And also we can enable moderation. And how we use this interface? We have assistant service, which is our business logic. We call this service from WebSocket endpoint, and we provide chat memory, we provide a question, some information about user. We need chat memory to differentiate the different user sessions. So the assistant is asking for specific user questions, not for questions from another user. And here we have business logic, and we use reactive channels, and we can send a question for processing at a later time and some other place. And also we can, we are calling our assistant, but we call chat async, and this is a suspend function. And how we implement it, we created, we wrap it with context coroutine function. So this is actually a pattern we can use to wrap almost any blocking code. We should be, of course, mindful about the dispatcher, about the thread pool used by this dispatcher. For example, if you are planning to use virtual threads, we should be mindful, is underlying code using any native calls, and if it is, then it might be a thread pinning, which is not good. So this is how we integrate our event blocking API from LangChain with a non-blocking server. And hopefully in LangChain4j version 2, we'll have asynchronous API, and we will not have to do it anymore. So now let me try another example. Some business scenario. For example, I don't have much time today, and I want somebody to call me back, and I want assistant to schedule this call. I don't have time today. Let someone call me tomorrow morning. So assistant is instructed that they may schedule call, but they need some information. They need my name, phone number, and preferred time, and the topic. I'm Konstantin. I'll give some phone number, which is not valid because it doesn't have country code. And let's say 10 a.m. and open bank account. So phone number provided seems to be missing the country code. Yes, and I'll provide. Oh. Come on, where is plus in this keyboard? Sorry. Denmark. Plus. This is Denmark.
Oh, you switched. Okay, go.
All right. Sorry.
There.
This is fun. Okay, and we have a call scheduled for tomorrow. And since we have dev UI, in dev UI we have embedded a SMTP server. Where is it? Yeah, here it is. And there is a UI. I can check the message. So the business process is sending a message to customer support email. And let's look at the code. So here we have a customer callback scheduler. It's a bean. We inject a mailer inside, and we annotate it with a tool, and we give description of this tool. And this description goes to LLM. So LLM can call this function. We also describe parameters of the function. And then we do validation, and we send array of strings, a list of strings back, and this list of strings comes back to the LLM. So LLM knows what's wrong, and we should respond with a human language, so LLM understand what other parameters they need to ask from customer, from the user. And let's try another example. For example, I'm not happy with your products. So what happens here, LLM is responding professionally, but also we can see that we have another email, and it's negative sentiment detected. Right, how we implemented this? As we see here, we send a message to the asynchronous channel, and then somewhere we have a processor which is receiving this message, and we call sentiment analyzer and send this question. And if sentiment is negative, then we send email. How the sentiment analyzer is implemented? Here we inject chat model directly into our business bean because we don't need this RAG thingy. We don't need to fetch documents and do moderation. We just want to call model, and we can specify model in a parameter, and it's in the configuration, it's just injected. It's very lightweight and cheap model. And then we call this chat model.chat, and this is already a suspend function. And the suspend function is implemented in LangChain4j Kotlin extension. So you can also use beautiful DSL. And let's see another thing. We want to run LLM requests, and we want to test LLM requests, but how we can test it? We can test, of course, with a real LLM, but it's expensive and it's not deterministic because LLM sometimes hallucinate. And also we may hit rate limits, especially if we run continuous integration tests in, let's say, GitHub Actions, and we want to run many tests in parallel. LLM has rate limits, and we want to test it locally. And with Quarkus, we also have nice continuous testing. So whenever I change the code, there is a test, and tests are run. And I test against the different parameters. And let me go to the test. So it's a Quarkus test, and I'm using mock OpenAI. It's a Moxie library, which is basically wire mock for language models and agent-to-agent protocol as well. So we create and start this mock HTTP server. Then we inject the server address as a OpenAI URL, basically. And then we have JUnit parameterized test with a reply and expected sentiment. So we can, here we simulate response from LLM. For example, if we receive this question, then we reply with same thing. And we run it. So this is how we can test LLMs, and we can run it also locally. Yeah, so very quick. And now let's ask really bad question, something scary. Will you fall? So I just want to trigger moderation. And we see that response is different. It cannot process this request because it's too bad. And how we implement it? We just added this moderate annotation. And what happens when we call this chat method, annotated with moderate, it can throw moderation exception. And we handle this exception and return a different response. And also, it was handled by our sentiment analysis. Yeah, also, it's quite negative sentiment. Slides, yeah. So this is how we can do integration testing with Moxie. So we can mock the request, and we get the response, and we configure our models. And this is it. So with very little code, we could build assistant, which is doing RAG, MCP, content moderation, conversation awareness, connects to LLM, and we can extend it more and more. It's also doing structured response. And this comes out of the box, so it supports Kotlin's serialization, so very useful.
Cool. Awesome. Yeah. So the main thing we've tried since forever we started Quarkus language or the effort on Quarkus AI very early on was to just show to people that Java works just fine with LLMs, and you don't have to, all the stuff you need to know about declarative interfaces and REST endpoints and Kafka messaging. That stuff you can access just as easy as you can access your LLM, and vice versa. So again, just to summarize the LangChain stuff, why LangChain4j? Well, it's the hyping of AI, and you can use it everywhere. There's a big, massive community of contributors to giving different support for the different model providers out there, and also adding more of these, like some of the guardrails is currently in Quarkus LangChain, but we're moving it down to LangChain4j, so it has that notion. Because that's something we do. We experiment a bit in Quarkus, where we can move a bit faster, and then we move it down to LangChain and vice versa, and how it works. It has the tools, embeddings. We didn't show audio and video, but you can do that too. MCP clients, agentic flows, etc. Right? And 1.0 was released last week. Apparently, last week and this week is the release of all AI Java in the space. And as Konstantin said, the next one of the next features in LangChain4j is to add proper async APIs. And that's one of the reasons, like he was showing how to use coroutines, like there's a little wrapper. That's what you need to do today. It works as it is. But in when the next version, Quarkus will be able to detect the different types that will be used in LangChain4j, and then all that wrapping will go away, right? But otherwise, for Quarkus, we do that for all the other libraries. There is already some async support that where coroutine fit in. It's just transparent, and you can use coroutines as you want to. Yeah, and then so why Quarkus LangChain4j? Well, all the stuff like the developer stuff, the AI, the mailer, what do you use more? You saw the mail pits, the whole dev service that showed up is also coming from Quarkus. And the fault tolerance, you didn't touch it so much, but all the annotation for like doing retries and handling, which is very important for LMs because sometimes they go down, is just kind of built in, and just use what's called standard Java patterns to do that, right? Metric tracing and auditing is a key thing in AI, and actually so to add any kind of telemetry to Quarkus comes with metrics and stuff, tracing built in. You add this in one of the recent Quarkus releases. We add this combined extension micrometer and OpenTelemetry, which means that all your metrics and logs and traces will be sent over OpenTel. There is a dev service in Quarkus. It's there. I'm not a fan because it takes 30 seconds to boot up the container. So I'm way more to the standalone text one. And actually, while Konstantin was demoing, it was actually this is an OTel TUI, which is basically just like you can use Grafana and all the visual stuff, but I like text. And you can see here where is one, for example, the LangChain service called the getter, and there was a tool call. No, this is moderation. That was happening, and I can probably go back and find one with a tool call. Where's one? That one. Tools. There's the schedule call, for example, right? So all the stuff that is in so LangChain4j doesn't have all that hooks into the OpenTelemetry and metrics. It has all the hooks for us and other frameworks to hook into, and that's what Quarkus does, right? And of course, I use a TUI here because that's just easier to demo. But if you had a Prometheus and a Grafana, whatever running elsewhere, you could just send it there and get all this data coming up for that one, right? The feature I show here is since Quarkus 3.20, but you could be using this earlier. But the micrometer OpenTelemetry is in 3.20 and forward. Yes, so there's the traces, there's the metrics, there's the Actually, that's just because it's fun. I'll do the here.
Norton commander of.
Yeah, you can see all the charts and stuff in the thing. Yeah, this is modern tooling, right? This is what this is. Yes, and then again, just the MCP server I talked about. Just so I've seen some example of showing Kotlin MCP as a gate. It's cool, but it's like 4 pages to do that. I prefer that one. So anyway, I'm here at KotlinConf to actually show that Quarkus has a really smooth experience with Kotlin. But what we want to get better at is to get people that knows Kotlin better than I or we do, and contribute extension method and stuff that, like you saw the data structure thing, that was possible by adding extension methods. We've added them when someone shows by, hey, I found that it was missing, and we've added them. So if you have any ideas to extension methods for LangChain or any other Kotlin library, any extension in Quarkus where it makes sense, we're very open for those kind of contributions. The LangChain4j, again, has some integrations that could be better. For that, again, people can contribute and show, and hey, this doesn't work, we can fix it. I'm actually trying to find someone from the Kotlin compiler team and build team, because you didn't see it here because it didn't have to compare, but if you reload in Java, it's like 3 times faster than it is in Kotlin, because the Kotlin compiler is not the fastest around, but I heard there's new things coming. So I want to make sure we hook into that part. And then the LangChain4j next, which is developing, is starting like tomorrow, because we've released 1.0 soon, is where we want to add the native async API, and that's when we can get the coroutine stuff in for the people that is important. But I want to remind everyone that you do not need coroutines and async for 90% of your applications. Blocking and virtual threads and that stuff still works. So we are not forcing anyone. So anyway, my whole point is that we can do a lot of stuff in Quarkus, and it already today works nicely with Kotlin. Cool. That's the link for all the talks and demos we did here. Yeah. So back to you. Any questions?